Hey everybody. Today we're getting started with probability, talking about sample spaces, outcomes, events, and a few other core concepts. To start, a probability experiment, or random experiment, is a trial for which the outcome can't be predicted with certainty, although over time certain trends may emerge. Some examples: flip a coin and record whether it's a head or a tail. Use a random digit dialer to contact 10 voters at random and ask who they're going to vote for. Roll 2 dice and record the sum, or roll 2 dice and count the number of sixes. Notice in those last two examples, we're doing the same physical activity, rolling 2 dice, but then the thing that we're recording at the end is different. The result of a particular trial of a probability experiment is called an outcome, and the collection of all possible outcomes of a probability experiment is called the sample space, or sometimes outcome space. And usually we denote that with S, a capital S. An event is a subset of the sample space. Now, all this gets a little bit more logical, makes a little more sense when we see an example. So let's do that right away. 2 coins are flipped and the results are recorded. So the sample space, the collection of all the possible outcomes, has 4 elements in it: heads, 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 tails, tails, heads, and tails, tails. If E is the event both flips are the same, that's something that can happen in 2 ways. That's heads, heads, and tails, tails. Technically, the way to say this is that the event E is a subset of the sample space S. Intuitively, an event is just something that can happen in a probability experiment, though typically it can happen in multiple different ways. So, for instance, in that last example, the event, both flips are the same, can happen in 2 different ways. But it is just sort of something that can happen. An event that just consists of a single outcome is called a simple event. So that would be something like both flips are tails. The complement of an event E, denoted E prime, is the set of all outcomes in the sample space that aren't in E. So if E prime occurs, then E does not, and vice versa. Here's an example of that. A spinner is used to randomly select an integer from 1 to 9. So the sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's let E be the event the result is a prime number. So a prime number is a number that's divisible only by 1 and itself. So the event E is 2, 3, 5, and 7. To get the complement, I'm basically just going through the set S and crossing out all of the things that are in E. And if I do that, I'm left with the complement E prime, 1, 4, 6, 8, and 9. The number of outcomes in an event E is denoted with sort of absolute value symbols. So in this last example where we had E was 2, 3, 5, and 7, and S was all the integers from 1 to 9, the number of outcomes in E is 4, the number of outcomes in S is 9. And that's notation that gets used continuously throughout your study of probability, so it's good to be comfortable with right away. 2 events are disjoint or mutually exclusive if they have no outcomes in common. So those 2 terms mean exactly the same thing. Let's wrap up with an example of that'll also help us brush up on these other ideas that we were talking about in this vid. 4 coins are flipped and the results are recorded. Let E be the event the first 2 flips are heads, and let F be the event there are at least 3 tails. So here's the sample space. It's got 16 elements, things like heads, 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 and heads, 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 tails. I want to write E and F as sets, and then decide if they are disjoint. So this is a good place to pause the video. Try this on your own. So for these 2 events, if E is that the first 2 of the 4 flips are heads, then we have 4 possible outcomes. Heads, 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 tails, and so on. If F is the event there are at least 3 tails, then we have 5 possible outcomes, which I've written here. And the way I organized my work on F was to do the 4 ways that we could get exactly 1 head and 3 tails. So I put the head last, then the head second to last, then the head third to last, and so on. And then after I wrote all those down, I wrote the other outcome in this set where all 4 of my flips are tails. And you can look at these and compare very directly that E and F have no outcomes in common, so these 2 events are disjoint. And this makes sense in light of the the English language definitions that we have here. If the first two of the four flips are heads, then there's no way that we can have at least three tails.